An object moving along a curve in the xy plane has position x of t, y of t at time t is greater than or equal to 0 with dx dt equals 3 plus cosine t squared. The derivative of dy dt is not explicitly given. At time t equals 2, the object is at position 1, 8. For part A, we are finding the x-coordinate of the position of the object at time t equals 4. So to do this, first we will set up an integral from 2 to 4 because we already know the initial position at 2. And when you solve that, you will get x of t solved at 2 to 4. And then you solve as so, and you get x of 4 minus x of 2. And then since we're actually solving for x of 4, when you rearrange things, that's where you get your x of 2 and the integral of dx dt. And what we just did was the second fundamental theorem of calculus. And then when you solve it, x of 2 as was given is 1 plus the integral from 2 to 4 of 3 plus cosine t squared dt. And when you solve that, you get your answer to be 7.13. For part B, we were asked to find an equation for the line tangent to the curve at the point x of 2, y of 2. We're told that at time t equals 2, the value of dy dt is negative 7. And dx dt we were already given is 3 plus cosine t squared. So when we plug in 2, we get this answer. And then what we're going to do is solve for the slope, which is dy dx at t equals 2. And that is dy dt over dx dt. And I found that to be negative 2.983. And then when you plug in the slope into the point slope formula, and we got the 8 and 1 from the initial position already given at t equals 2, and you get your equation y minus 8 equals negative 2.983 times x, the quantity x minus 1. For part C, we were asked to find the speed of the object at time t equals 2. Well, speed is just the magnitude of velocity. So we are going to take the square root of dx dt squared plus dy dt squared. And then when we take the magnitude of velocity at 2 and plug in 2 for t, then we get 7.383. The 3 plus cosine 2 squared is dx dt, and the negative 7 is dy dt, which was given earlier in the problem. For part D, we were asked to find the acceleration vector of the object at time t equals 4. For t is greater than or equal to 3, the line tangent to the curve at x of t, y of t has a slope of 2t plus 1. So the acceleration vector is going to be x double prime of t and y double prime of t. So starting off with the x's, when we take x double prime of t, we get negative sine t squared times 2t. This was taking the derivative of dx dt of 3 plus cosine t squared. And then when we solve for x double prime of 4, we plug 4 in for t and get our answer to be 2.303. And then since we know the slope is 2t plus 1, that is equal to, that's dy dx, which is equal to dy dt over dx dt, which we already know. And so then we're able to solve for dy dt by rearranging this equation, and then by taking the derivative of this in our calculator, since it's a calculator problem, and then finding that derivative at 4, we get y double prime of 4 equals 24.814. So our acceleration vector at 4 is 2.303, 24.814.